Welcome to Stars Launch Pod, where we chat with innovators who are overcoming challenges, pushing boundaries, and collaborating to make space more accessible and sustainable for humanity, one launch at a time.
It's one small step for man.
Here's your host, Susan Wise.
Welcome to Stars Launch Pod, Space, Technology, and Research Sciences, brought to you by starsciences.org, where we connect, collaborate, and accelerate. I'm your host, Susan Wise, and with me is Joe Dynamic Space Pawelski. Did I say that right?
You sure did. Thank you.
Co-founder and CTO at CisLunar Industries. His academic pursuits in engineering from Rochester Institute of Technology and space resources management from Colorado School of Mines have honed his expertise. Ultimately, Pawelski is motivated by the transformative potential of space technologies and their ability to shape humanity's future, driving him to push the boundaries of aerospace and defense innovation. Welcome to the show. How you doing, Joe?
Doing great. It's a pleasure to be here. Thank you.
What are you working on right now to further the space industry? And tell us more about CisLunar. Explain to us what that is and what you do.
Absolutely. So CisLunar started as an in-space resources company, in-space manufacturing. We realized that mass is one of the most costly things to doing space. Now, SpaceX has really helped to lower that cost and make it more accessible, but it's still $6,000 to $7,000 per kilogram. And that's just to get to low Earth orbit, which is sort of where space begins. If you want to get out to GEO, it can cost twice, 3 times, way more than that. If you want to get to the moon, it could be 100 times as much. So moving things around in space is very expensive, which makes us look towards how do you assemble things in space? How do you reduce how much mass you have to launch? How can you do in-space manufacturing so you don't have to keep launching things? So that's really how CisLunar got started. My whole thesis was, hey, the best way to keep this Earth as an awesome place for people to live, because right now we don't really know of any other places that we can get to anytime soon that would be good places to support life. So there's many thoughts on how to save the world. I figured the best way to save the world is to get our energy, our resources elsewhere. That's something I think we can all agree on, and keep the Earth for living by using things like energy. The sun produces a ton of energy. There's a ton of resources on the moon and asteroids and things like that. So let's use those so that we don't have to do the things that use resources on Earth, and we can use the Earth for living. It was really the basis for CisLunar. So anyway, we started out, we thought, what did the original industrialists do? Well, they focused on materials, steel. Steel is really what built the industrial backgrounds of the United States and the rest of the industrialized world. Steel is not very abundant in space, but aluminum is, it turns out. Aluminum oxide is abundant on the moon. And I was thinking, again, power was really what I was after. So for power beaming, harvesting energy from the sun, returning that energy in the form of electrons back to the Earth, large structures that could harness that, big reflectors, things like that. Well, aluminum is a really good material for that. And so our original work with NASA was actually to harvest space debris, which is predominantly metal, and also to look at the lunar surface, aluminum oxide, how to reduce that and turn that into metal, and then how to build things with that metal in space. So that's how we started. And what's interesting, though, is we ended up making a pivot, because what happened was we realized using electricity to do this, using electromagnetic induction, we made a tractor beam to actually pull the stuff into the furnace because there's no gravity in space. Anyway, the team that I hired was all mostly electronics engineers. We came up with all this really interesting electronics, high voltage, high power, very big magnetic fields. And we realized, hey, wait a minute. The actual foundation of space manufacturing and space economy is truly power. And we realized that what we're really good at is transforming power to run space. So currently that's what I'm working on, is how to transform power to run space. The amount of power you have on a spacecraft really dictates how much you can do with it. So right now, we started out with much smaller, a lot of commercial space really started with CubeSats that run at the tens of watts, hundreds of watts, maybe max. To really do interesting things in space, we need kilowatts or megawatts of power. And that's what we are focused on building. So currently, and higher voltages as well to transfer that kind of power. So currently, the 2 really cool projects that we're working on Hall thruster power processing units. So these are the things that take the electrons that are generated in a solar panel, and they convert those to hundreds of volts to make plasma in order to move a spacecraft with plasma thrusters. So straight out of Star Wars or Star Trek, we use plasma thrusters to move the new satellites around in space. It's the real thing. They've been around for a while, and now they're becoming prolific. SpaceX uses plasma thrusters on all their satellites.
It reminds me of Apollo 13, when we've come a long way, when they said you have, you know, this much wattage to do this, and this is what it takes to run a vacuum cleaner. So
Exactly. So that's a good way to put it too, is, you know, some of the largest spacecraft out there maybe are about the power of a vacuum cleaner for commercial space. Certainly there are some defense satellites that are pretty powerful, but there's only a few of those and they're very expensive. We need to get to the point where commercial space is operating spacecraft that are in the tens of kilowatts and larger. So that's the kind of stuff that we do. And again, a lot of these things, they move around. So being able to move around in space is expensive. Getting a rocket to get something to LEO, that's $6,000 to $7,000 per kilogram. And then once you get there, you can use your own propulsion on your spacecraft. Once you're out of the Earth's atmosphere and you're in orbit, now you can use something like a plasma thruster to move you to GEO for a lot less money than it would cost to use a rocket. And if you have more power, you can move bigger things faster with the plasma thruster type of technologies that we work on. So plasma thruster is super cool, straight out of Star Trek, Star Wars. The other project that we're working on right now is a very high voltage power supply that's designed to operate X-rays. So that's been super neat. This is over 100,000 volts, which operating over 100,000 volts anywhere is pretty hard. It's been quite the challenge. Operating that in space is even harder. So we're one for challenges.
Where exactly do you test this stuff? I mean,
we test it right here in our labs. Yeah.
Okay.
Yeah, exactly. So there's a lot of different test equipment we use. Normally there's vacuum chambers involved. So sometimes we even test things, and getting zero gravity is always a challenge, but we've actually done parabolic flights with zero G. This is also known as the Vomit Comet. You mentioned Apollo 13.
Yeah.
That movie was largely filmed in the Vomit Comet, lovingly referred to because a lot of times people get sick. So yeah, that's where we fly in order to test zero gravity, which is important for things like in-space manufacturing, deploying solar panels, things like that. You really need to see how things are going to react in a zero gravity environment. But for what we do with electronics, a lot of times the thermal aspects, like heat rises on the ground. Heat doesn't rise when there's no gravity. So that's something that we have to be aware of. But normally we're in a vacuum environment. So we typically only get radiant heat transfer instead of, we're in an environment full of air. So there's convection, the air moving against your hand is where a lot of the heat goes. So you can have a fan blowing on something to cool it off. And then also you have conductive heat pass, where the, like a wire, heat moves through metals and things that are conductive as well. So anyway, a vacuum chamber, it actually turns out if we take the vacuum down to similar as a space environment, that's one of the things we use to test. But otherwise, a lot of times it's really electronics testing that we're doing. So we have this thing that looks like a Van de Graaff generator in the other room. It's this big metal ball that's about this diameter, and it's on a tower. It looks very impressive. It's just a big resistor. But when we work with voltages at that level, it's called a corona discharge. Any kind of sharp point, and depending on the voltage, the more you have to have like a round surface to prevent these discharges from happening. So when you get up to hundreds of thousands of volts, you need pretty big round surfaces to prevent that from happening. So that's how we test a lot of times. There's interesting probes and things that we have to use so we don't electrocute ourselves or shoot lightning bolts across the room. But otherwise, it's a lot of oscilloscopes and test equipment, things like that we use.
So you have had your challenges along the way. What's been one of your biggest challenges, and how did you overcome it?
Well, everything in space is somewhat of a challenge. I mean, we joke about this all the time. How many rocket science does it take we're like, oh, wait a minute. I guess we are building rockets and stuff. Recently, high voltage has been very challenging. I'd say that we have some very seasoned experts here working on this sorts of thing. They've done high voltage since they were in grade school, but designing something that can't off gas, that has to have certain materials because they have to be launched, that's been very challenging. And working with high voltage is similar to working with very high pressure fluids, for example. If there's any kind of a crack, they'll break it open and escape. Yeah. Same thing with high voltage. If there's any kind of conductive path, even if you have oil from your skin, if you don't set up your epoxies or your silicone, whatever your insulator is, it'll break free. And then that high voltage gets out and it wrecks everything. So that's been the latest real butt kicker that we've done, is this super high voltage thing. But then again, we did make this thing 5 times smaller than the next available thing on the shelf. So
That's the important thing, right?
yeah, it's the smallest super high voltage unit that I think anyone's ever made, which is
Wow.
cool. Yeah.
What was your aha moment?
I think our aha moment was when we were performers for DARPA Luna 10. There's a book about this that's called the Luna 10. Really interesting point. It turns out 40 years ago. So right when I was a really little kid, this study came out about how we would sustain life and have some industrial footprint on the moon. And of course, it didn't happen in the 80s like everybody thought it would, unfortunately. But now we're invested in space again. And so this book came out as to how to do that 40 years later. And we actually got to publish an article on it. And I guess the big aha moment, we realized that, hey, wait a minute, if we have enough power, we can do all kinds of advanced manufacturing. We can make metal to build these big reflectors and solar panels and whatever we want to do. But we need like at least a megawatt or so of power on the moon in order to do that, or power in space, et cetera, in order to really make it cost effective to manufacture there. Below that level, there's an argument that, especially with some of the bigger rockets coming online and stuff like that, that it's cheaper just to launch stuff there and have it be sort of disposable. But once you get to enough power, and then it scales from there. Once you get to 100 megawatts, all of a sudden it's like 10 times cheaper to make things on the moon, and it scales from there. So that was the aha moment. We were like, hey, wait a minute, like all this stuff, all the hard stuff that we've been doing that nobody else has been doing has actually been around transforming power. What if we just focus on transforming power to run space? And like, we actually have people that need that now. And so that was a big aha moment. If we build that, that's actually, it's not, metal was the industrial foundation of the Industrial Revolution. The foundation for the space revolution is literally power. And you see that people like data, AI, everything else, it's all limited by how much power we have now at this point.
What's happening right now? Is there something going on right now that you'd like to share?
Yeah, currently we have a payload. It's already on a SpaceX rocket. It will launch at the end of the month if things keep going on as scheduled. Our payload is a 1 kilowatt power processing unit for a Hall thruster. So one of these plasma thrusters. And this will be the first time that we've flown a power processing unit for a Hall thruster. We've flown 2 other units before that were for E-beam welders. So that was pretty awesome. But this is the biggest payload we've flown yet. And it's the first payload that's been ours totally. We've built payloads that were integrated in other people's payloads, but this is the first one that's all CisLunar. I know we have 2 others coming up this year that are already on schedule that we have contracts for and we're actively building. We have another plasma thruster that's launching. This one's really cool because it runs on the customer, the end user. It actually uses water and it turns that water into hydrogen and oxygen. It runs a Hall thruster, plasma thruster, and a chemical thruster. So it can get really high thrust by burning hydrogen and oxygen, like, old school rockets do. And it can use it as electric propulsion as a plasma thruster by ionizing that. So it can get very good fuel economy and as an electric propulsion system. And we're also flying that super high voltage X-ray system with a partner of ours in October as well. Yeah, I expect we have a number of customers that want things this year. They're pretty ambitious missions, but we've been known to get things done pretty rapidly. So we might have a few more flights happening this year. So that's definitely putting stuff on a rocket, seeing it in the stack has been really, really cool.
Got some crazy work ahead of you. Lots of things going on. That's exciting. You have any advice you'd like to share with our listeners?
Sure. I think the main thing is spend more time doing the things you like doing and less time doing the things you don't. I don't have very many regrets in my life, but the one thing I do kind of regret is not starting this company and doing it sooner. I realize at this point that I could have. The only thing holding me back was being worried for whatever reason that maybe it'll be harder than I think. Just go do it. That's my mantra. Go do the things that you want to do. Yep.
Did you always know you wanted to go down this path?
I did. Yeah. My first career that I wanted to do is I wanted to be a music man, like the old Disney movies where like the guy had the drum and he did all the stuff, played the horn at the same time. My dad bought me one of the Estes model rocket sets. So probably like half the listeners here, they're into space. Estes rocket that I was like, oh, wait a minute. I want to do that. And so, yeah, right around 5.5, something like that. I was just 100% into doing space. I knew I wanted to be an engineer. I was a thermal fluids engineer is what my actual first master's degree was in. But I was always intrigued by high voltage and electronics. And it was something where I dream in SolidWorks or whatever. I can see mechanical things and gears and whatever and figure that out. But electronics was always something where it was a challenge. It's like, I want to learn more about that. So in high school, I built Tesla coils, which make lightning bolts. And
in high school.
Yeah. And I got introduced. I grew up in Richmond, Virginia, which is near DC and near a bunch of like Navy Research Lab and Picatinny Arsenal. So I had these mentors that I met through Tesla Coil Builders Richmond that were building all kinds of really neat stuff. And now we actually did some work with Navy Research Lab and all these people. But at the time, when I was 13, it was the first time I ever did any real high voltage stuff. I got to meet these people and they were awesome. And they were, they're actually working on railguns and lightning, real fascinating things for that. But then they had these hobby pursuits that they would do. So one guy actually, he built the first hobby fusion reactor. After he got tired of making lightning machines, he was the first one to do fusion in his garage.
I was going to say, in his bedroom? Where'd he do this?
It's just this garage attached to his house. So I got to meet all those people as a teenager. And then enough, you can guess where I find my talent. I go back to the well and say, hey, so one of our lead engineers here, chief scientist, actually came from that community. And he's the guy who invented the thinking Tesla coils and the quasi-continuous way. So these things like the thing that it shoots like a sword, like lightning bolt out of a lightning gun and all kinds of things. A lot of YouTubers that do these things figured out how to do it from him. So we got to know each other that way. But so that would be the other thing is like, if you see something cool, find out who did it, find out who does it best and make them your friends. I mean, that's all. Get as close as you can to the things you like doing. And that's the best way to get into it. Yep.
Surround yourself with lots of smart people.
Yep. In the field that, smart, cool people that do what you like doing. Yep.
Before we wrap up, I'd like to ask you also, Joe, do you have a passion project, either past or present, that you'd like to mention?
Oh, man. Right now, I guess my passion project is building CisLunar Industries, which sounds cheesy, but that's primarily where this is the first time, I've had several other careers. I was in high-speed manufacturing. I've had things on the How It's Made channel and things like that, which are really cool. And while I was doing that, my passion project was always making lightning machines and high energy type experiments. And now I have a whole lab and a whole group of engineers that are building these things. So I get to come in and see how they did it. And it's super cool.
Have you made a lightsaber yet?
Well, the lightning gun is a little bit like a lightsaber.
I was thinking that when you said that.
Yeah, it makes lightsaber like lightning bolts it's pretty similar. Hey, maybe that's what I should do next is build a lightsaber. I do have a bunch of ideas of things that like, maybe when I have some free time, I'll build something like this. So I built some go-karts that are ridiculously fast with my kids.
Oh my God.
I am an avid sailor, which is funny because we live in Colorado. My boat is electric. Of course, it's a sailboat, but it has a solar powered electric motor for auxiliary power that I put in there.
Of course it does.
Yeah, because why not? So it's great. It's super silent. We have a race where we're allowed to cheat, and I usually win because as long as nobody can tell what you're doing, so having the electric motor that's totally silent, I'll have just one sail up, and I'll be passing the racing boats that have all their sails. And you're like, what is going on? I
gotta say, Joe, you are a ball of energy yourself. Okay,
thank you.
Trying to contain you has been interesting. But no, I love it. I love your enthusiasm and your energy and everything that's going on with CisLunar. And we're excited to hear your story. Thank you so much for sharing it with us today.
Absolutely. Thank you for the opportunity.
Make sure you join us where we connect, collaborate, and accelerate. And if you enjoyed this episode, leave us a review and subscribe. Till next time, keep looking up.
Don't miss an episode. Subscribe on your favorite streaming platform. Watch us on YouTube. And follow us on social media. Stars Launch Pod, propelling us forward, one launch at a time.